Today we'll discuss about the electrical potential. Now, what is potential? You see, before that, we must know what are the topics we are going to read here. I have mentioned here all the topics in almost uh, in the abbreviated form. Like first, we must know what is the definition of potential, then what is the relation between the potential and the electric field, then what is equipotential surface, then we must calculate the potential for dipole, and similarly what we have done for the electric field, the potential for a sphere inside, outside, and on the sphere, and also the energy of a dipole placed in an external electric field, and also the energy density E by V. I have lastly mentioned that E by V, which is equal to half epsilon E square. So first we discuss what is definition of electric potential. Suppose this is an electric field, and there is a charge for which the electric field has been created. Now, to calculate the potential for a particular surface, say this is a particular point, this is P, we must bring an unit positive charge from infinity to that particular point. So, the definition of electric potential is the work done, minimum work done per unit charge. Unit positive charge, we must bring the unit positive charge from infinity to that particular point, and for that the minimum work done is called the electric potential for that point. Now, what is the difference between potential and field? Well, the field is, field is basically created by the effect of a charge, the main charge, and potential is something you can call, it is the measure of the ability of that particular field. And here also I must say that the potential, look at this, I have mentioned in dV, not the V. Why dV? Because potential is such a quantity which cannot be measured exactly at a point. Because it is actually, we always, whenever we want to calculate a potential for a particular conservative force field like electric field, magnetic field, gravity, whatever it is, we are calculating the potential of a particular point not in exact value, but actually it is the difference between the potential from a certain reference level. And here the reference level is actually infinity. So we are calculating the difference between the potential of infinity and at that particular point. So that's why we should write dV, but actually you will look in the book also, and you will see in the problems we eventually go to write here in V. So that's not a big deal, but whatever, we must know what is the dV, not the V. So now the first part, this is the first part gone, and now the second part is what is the relation between electric field and the potential. For that I am taking, so this is a continuous force field E, and we want to move a charge from A point to B point. Now, what is the potential of that point? So this is VA and this is VB, and the distance between these points is R. We know the relation between the force and the electric field is F is equal to QE. So the work done to bring a charge from Q from A point to B point is basically Q into EA minus EB. This is the force required. And the work done, what is the work done? Work done is basically force into displacement. So dW, if the dW is the work done, is equal to force into displacement is R. So Q into EA minus EB into R. And we write it this. So E is equal to minus dV because here as we know dW, what is dW? dW is here dV into Q. It is dV into Q. So Q and Q just eliminating here, and EA minus EB is equal to dV by R, and we can write this because if we take this is dE or E whatever and equal to dV by V. And why minus sign is here? Because we always try to go from a point which has the greater potential to a lower potential. That's why work will be done against this force, the force of the field. That's why we put minus sign here. So this is the relation, very important one.